Hi everyone, my name is Sona Mathew. My topic is of Condor, which is one of the popular software systems supporting task computing framework. Coming to the introductory part of the Condor, Condor is a specialized workload management system for compute-intensive jobs. Like other full-featured batch systems, Condor provides a job queuing mechanism, scheduling policy, priority scheme, resource monitoring, and resource management. Users submit their job to Condor, and Condor places them into a queue, chooses when and where to run them based upon a policy, monitors their progress, and ultimately informs the user upon completion. So briefly telling about the meaning of the Condor, Condor is the most widely used and a long lead middleware for managing clusters, ideal workstations, and a collection of clusters. Condor is one of the versions of the Condor supporting the integration with grid computing resources such as those managed by Globus. Globus is nothing but it's also one of the popular software system providing or supporting task computing framework. Coming to the architecture part of the Condor, as you can see, the architecture which contains of the three main components or the machines. The first one, to be precisely speaking about the central manager. Central manager job is to detect the ideal machines and match the job requirement to available resources. The second one is the submit machine, which only submits the job. And coming to the third one, it's full install machines which submit and run the jobs. Speaking about the features of Condor, the first one is the class aids. The class aid mechanism in Condor provides an extremely flexible and impressive framework for matching resource requests with resource offers. So second one is the distributed submission. There is no single centralized submission machine. Instead, the Condor allows the jobs to be submitted from many machines and each machine contains its own job queue. Users may submit to a cluster from their own desktop machines. Coming to the user priority, which is one of the main or important feature of the Condor. So administrators may assign priorities to user using a flexible mechanism that enables a policy of fair share, strict ordering, fractional ordering, or a combination of policies. So the next feature is of job priorities. Users can assign priorities to the submitted jobs in order to control the execution order of the jobs. A nice user mechanism requires the user of only those machines that would have otherwise been ideal. Then comes the job dependency. Some set of jobs requires an ordering because of the dependencies between the both the jobs or the set of jobs. Next one is the supporting for multiple job models. So your Condor handles both serial jobs and parallel jobs, incorporating PVM, dynamic PVM, and MPI. Authentication and authorization is also one of the main features of the Condor. Administrators have fine-grained control of access permissions, and Condor can perform strong network authentication using a variety of mechanisms, including Kerberos and Extra 509 public key certificates. Coming to the next feature is pools of machines working together. Flocking allows jobs to be scheduled across multiple Condor pools. It can be done across pools of machines owned by different organizations that impose their own policies. The next one is the heterogeneous platform. In addition to Linux, Condor has been ported to most of the other primary flavors of Unix as well as Windows NT. Grid computing. Condor incorporates many of the emerging grid-based computing methodologies and protocols. Now coming to the main topic, that is the Condor software. Research in distributed computing requires immersion in the real world. To this end, the Condor project maintains, distributes, and supports a variety of computing systems that are deployed by commercial and academic interests worldwide. These products are the proving grounds for ideas generated in the academic research environment. The project is best known for two products. The first one is the Condor High Throughput Computing System, and the second one is the Condor G Agent for Grid Computing. So we will now see about the two products. The first one is the Condor High Throughput Computing System. The Condor is a high-throughput distributed batch computing system. While similar to other conventional batch systems, Condor's novel architecture allows it to perform well in environments where other batch systems are weak. High-throughput computing and opportunistic computing. The two goals are naturally coupled. High-throughput computing is most easily achieved through opportunistic means. This requires several unique and powerful tools. So as you can see, there are three unique and powerful tools. The first one is class X, second one is the job checkpoint and migration, and third one is remote system calls. So coming to the first one, class adds. The class add language in Condor provides an extremely flexible and expressive framework for matching resources request with resource offer. So second one, the job checkpoint and migration. With certain type of jobs, Condor can transparently record a checkpoint and subsequently resume the application from the checkpoint file. The third one is the remote system calls. While running jobs on remote machines, Condor can often preserve the local execution environment via remote system calls. So now speaking about the second product of the Condor software, that is nothing but the Condor G agent for grid computing. So this is the figure, as you can see, which is an Condor in the grid. Here we can see that the Condor technologies can be exist both in the front as well as in the back ends of a grid, which is depicted in the figure. Condor G represents the marriage of technologies from the Condor and the Globus projects. From Globus 29 comes the use of protocols for secure inter-domain communications and standardized access to a variety of remote batch systems. From Condor comes the user concerns of job submission, job allocation, error recovery, and creation of a friendly execution environment. The result is a tool that binds resources spread across many systems in a personal high throughput computing systems. So as I have already said, Condor technology can exist at both the front end as well as the back end of a grid, as it is depicted in the above figure. Condor can be used as the reliable submission and job management service for one or more sites. The Condor high throughput computing system can be used as the fabric management service for one or more sites, and the Globus toolkit can be used as the bridge between them. Thank you.